Welcome to this video on dividing complex numbers. Let's begin. Simplify 2 plus I divided by the quantity of 3 minus 4i. Take a minute and think about how you might proceed. Well, in order to divide two complex numbers, we can't directly do that. Instead, what we have to do is we have to multiply both the numerator and the denominator by what is called the complex conjugate of the denominator. The complex conjugate of any complex number a plus bi is a minus bi. To find the complex conjugate, what we do is we change the sign of the imaginary part of the number. The sign of the real part of the number does not change. So before we finish this example, let's take some practice of finding the complex conjugate of different numbers. So again, in general, any complex number a plus bi has a complex conjugate a minus bi. Notice that a does not change at all, but the sign of b does change. Okay, what about 3 plus 2i? I encourage you to pause the video and try to do some of these on your own, and then unpause the video and see if you're correct. Well, the complex conjugate of 3 plus 2i is 3 minus 2i. Again, the sign of the 3 stays the same. The sign of 2i changes. This is plus, this is minus. They need to be opposite signs. What about 4 minus 5i? What's the complex conjugate of that? If you said 4 plus 5i, then you are correct. Again, the sign of the 4 does not change. The sign of the 5i does change. What about negative 2 plus I? Well, again, the sign of the real number does not change. It stays as negative 2, but the sign of I does change. So this becomes negative 2 minus I. What about negative 4 minus I? Again, the negative 4 stays the same, but the sign of the I changes. So it becomes negative 4 plus I. That's the complex conjugate. Please note that even if something were written as, for example, I plus 2, the order is not the important thing. The important thing is which is the imaginary term and which is the real term. So the complex conjugate of I plus 2 would be negative I plus 2. Again, it's not the first or the second term, it's the real part and the imaginary part. The real part has to stay the same. The imaginary part has to change its sign. Why do we have to multiply by the complex conjugate? Multiplying a complex number by its complex conjugate will always give you a real number. In other words, it eliminates the imaginary part of the number. This is only achieved when we switch the signs of the imaginary term. So let me show you with a simple example. So let's say I have 1 plus I times 1 minus I. Let's see what happens when we multiply these. So I'm going to do FOIL. So first terms is 1 times 1. 1 times 1 is just 1. Then we have our outer terms, 1 times negative I, or minus 1i. Bring that down. Then we have our inner terms, that's plus 1i, plus 1i. And then our last terms, so we have a positive I times a negative I. So positive I times negative I. So that's going to give us negative I squared. So remember, right, the I squared is equal to what? Well, I squared is equal to negative 1, isn't it? So we're going to bring down the 1. Notice that these middle terms, these inner terms, cancel out. Negative 1i plus positive 1i is 0. So we have 1 minus negative 1. So we have really 1 plus 1, or 2. Let's see if the same magic happens if I try to multiply 1 plus I times itself. In other words, if I don't change the signs. So I have 1 plus 1 is 1. Then we have our outer terms, plus 1i. We have our inner terms, plus 1i. And our last terms, plus I squared. Okay, so I'm not going to finish this. I just want to show you that when we do this, if we don't change the signs, right, that these don't cancel out. Plus 1i plus 1i is 2i, right? So we would have 1 plus 2i and then minus 1. So we would actually end up with an imaginary number, and we can't have that. Okay, so that's why we have to have opposite signs. That's why we use the conjugate, again, where we change the sign of the imaginary part. If you try to just duplicate it and multiply by the same exact term, you are not going to achieve the desired effect, which is eliminating the imaginary part. All right, so let's go back to this first example. So we have 2 plus I divided by 3 minus 4I. So take a minute, pause the video, and see if you can identify the complex conjugate of the denominator. If you said the complex conjugate is 3 plus 4I, then you are correct. Remember, we have to multiply both numerator and denominator since we have an expression, right? And really, this is just multiplying by 1, which doesn't change the value of the expression. So this is very similar to what we did with radicals. If you remember rationalizing the denominator, it's pretty much the exact same procedure, okay? So that means that we have two problems, basically. We have to use FOIL on the numerator, and we have to use FOIL on the denominator. And I moved the expression up there so I'd have more room to work. So when I multiply the numerator, let's go ahead and do this. We have 2 plus I times the quantity 3 plus 4I. Okay? So again, we're going to do first 2 times 3 is 6. Okay, then we have outer, 2 times 4I is 8I. Okay, then we have our inner, plus 3I. And then we have our last, it looks like it's plus 4I squared. All right, so 8I plus 3I, we can combine those. So we have 6 plus 11I. And then remember, anytime I see that I squared, I can't leave him alone. I have to replace him with -1. Remember, if you don't do that, you're not going to get the right answer. You're not going to get your points. Okay, so we have 6 minus 4 is 2, so the numerator is 2 plus 11I. Now you might be thinking, but there's still an imaginary part. That's okay. We don't care if the numerator has an imaginary part. We only care that the denominator does not. Okay? So let's look at the denominator here. So we're going to have 3 minus 4I times 3 plus 4I. So when we do our FOIL, we're going to have 9 plus 12I minus 12I minus 4I times 4I. Okay? So what you're going to find if you do a bunch of these problems, you're going to get used to the fact that these inner terms cancel out. Okay? So if you wanted to save a few steps and just skip the inner terms, you could just start by writing 9 minus 4I times 4I. Okay? So then we have 4 times 4 is 16. So we have 9 minus 16I squared. Okay? Remember I squared, well, what is I squared? I squared is just -1. Okay? So I'm going to have 9 plus 16, which is 25. Okay, so let me draw a little line here so it's very clear which one is the numerator and which one is the denominator. Okay, so I'm going to come back up here and write up my answer. So the numerator for my final answer is 2 plus 11I, and my denominator is 25. Now sometimes these problems will ask you to write it in the form, write your final answer in the form A plus BI. So if I had to do that, how would I do that? How could I do that for this problem? Well, what I can simply do is I can write this as 2 over 25 plus 11I over 25. So what does that mean? That means that A is 2 over 25, okay, and B is going to be 11 over 25. Okay? So if you ever have to do that, again, on paper, I would completely accept this as my final answer. That's fine. But if the directions explicitly say, express your answer as A plus BI, then you can just do this last extra step to get that. All right, let's do another example. This is pretty much identical to the one we just did. I want to encourage you, now that you've seen one example, to try to work this out on your own before watching this part, and then unpause the video or skip, fast forward through it to the end and check your work. Okay? All right, so what we're going to do is we are going to multiply by the complex conjugate. Sorry about that. I'm left-handed and it's really annoying. So the complex conjugate, as you probably already realized, is, oops, it's not 2 plus 3i. It's 2 minus 3i. Okay, so we're going to have two parts, right? We're going to have our numerator, so let's do the numerator work over here. Okay, so that's going to be 1 plus I times the quantity 2 minus 3I, and then later we'll do our denominator. All right, let's get started. So we have 1 times 2 is 2, negative 3I times 1 is negative 3I, plus 2I minus 3I squared. Okay, these inner terms combined, it gives us negative 1I, or just negative I. And then remember, we have to always replace the I squared with negative 1. Again, if you don't do that, you're going to get in trouble. You're not going to get the correct answer. So we can rewrite this as 2 plus 3 minus 1I, or minus I. So the numerator is going to be 5 minus I. Okay, so let's work on our denominator. So our denominator is 2 plus 3I times the quantity 2 minus 3I. Okay, so remember I told you if you find the correct complex conjugate, that means your inner terms are going to cancel out. So we can take a little shortcut here, say 2 times 2 is 4, and then just look at the last term. So we have plus 3I times negative 3I. Again, knowing that those inner terms are canceling out. So this gives me 4 minus 9I squared. Remember that I squared is always replaced with negative 1. This becomes 4 plus 9, or 13. So, my final answer is 5 minus I divided by 13. Again, if the directions specify that we need to express it in the form a plus bi, we can just break it apart. So my a is 5 over 13, and my b is 1 over 13. Okay. If you wrote it as, I guess you could also write it as 5/13 minus I over 13. That would be also a valid answer. But if it's asking you to write out what is A and what is B, you would have to say that A is 5 over 13 and B is equal to negative 1 over 13 if it asks you for A and B. Okay, example 3. This one's a little bit different. This says, how do we find the complex conjugate of a purely imaginary term? So pause this video, think about this question for a little bit, say out loud or write down your guess, and then unpause the video. So technically, right, if you think about 5i, right, and think about writing it as a plus bi, right, well, the a part is 0, right? So if you have a plus bi, then you could make the argument that the complex conjugate is a minus bi, or 0 minus 5i. We could make that argument, right? It makes sense. So let me just look at what would happen, what it would look like if I multiplied everything by negative 5i. So here is the original equation, okay? Let's look at multiplying by negative 5i, negative 5i. Do you notice anything? Do you notice how these negative 5s would just cancel out? Do you see that? And if you think about it, 5 is not the problem, right? 5 is fine. He can stay there because he's just a number. He's an integer. Right? The problem is the I. So you could multiply by negative 5i over negative 5i. That is a valid method. But if you keep that negative 5 there, you're just going to end up canceling it out. You're going to do extra work at the end, basically. Okay? So again, you can do it that way if you want to use that argument. That's fine. I always just multiply by I over I. And I'm going to show you, okay, so you don't believe me, I'm going to show you that it still works. Okay? So here's my original equation. Okay, again, instead of multiplying by negative 5i, I'm just going to multiply the top and the bottom by I. That's it. Okay? So let's look at what happens with our numerator. Okay, so I have I times the quantity, negative 2 plus 3i. That's negative 2i plus 3i squared. Remember, you can't ever leave I squared. You can't leave him there. You have to replace him with negative 1. So I have negative 2i minus 3. Okay, I like to always write it in a plus bi form. In other words, I like the real part first and the imaginary part second. So that's going to be my numerator. What about the denominator? That's what we really care about, right? Because this has all been in vain. It's been a waste of time if, I don't know why I wrote that, if the denominator doesn't end up being a real number. So let's make sure this works. So 5 times I is 5i squared. Well, I squared, remember, it's just negative 1, so the denominator is going to be negative 5. So lo and behold, this method works. Okay, so the numerator is negative 3 minus 2i. The denominator is negative 5. Okay, so this is a perfectly acceptable answer. I don't need you to do any more work, but if your directions at some point say write it in the term in a plus bi format, then we'll have to do a little bit more work. It would be negative 3 over negative 5 minus 2I over 5. No, sorry, negative 5. So really, since everything is negative, this might be a good thing to do anyways, just to get rid of all the silly negatives. So this is 3/5 plus 2/5 I. So if anybody asks you for A and B, the A would be 3 over 5, and the B would be 2 over 5. So let's do another example just like this. So again, the complex conjugate technically would be positive 7i. So if you want, you can multiply top and bottom by 7i. But that's really going to waste your time. It's going to give you large numbers. And again, you can see these 7s just cancel out. So we're just going to take the shortcut method and multiply top and bottom just by I. Okay. So let's look at just the numerator. Okay, so we have I times the quantity, 3 minus 2i. So that's going to give me 3i minus 2i squared. Remember, I squared, you have to replace it. You can't leave it in your answer. So that gives me 3i plus 2. Again, I always want to write it in a plus bi. I want to put the real part first and then the imaginary part. So that's going to be my numerator. Okay? For my denominator, I guess I should label this here, denominator. Okay? So that's going to give me negative 7i squared. Remember, I squared is negative 1, so that gives me positive 7. Okay, so my final answer is 2 plus 3i all over 7. If you're asked to break it into a plus bi form, we can do that quite simply. And then in this case, a would be 2 over 7 and b would be 3 over 7.